Assalamualaikum and very good morning. My name is Malaysia. I will present a few introduction. Okay, first of all, is background. Losing a hand is an extremely painful situation that affects either a person's physical life and emotional well-being. Therefore, having a connecting hand with a similar function as a hand loss is important. In a wide variety of activities, from performing heavier works to smaller movements, the human hand is a very fragile and nouns nouns component of the body used every day. Making a human hand is a challenging and difficult job due to all variables playing a part in how amputated life their life. As a reason for not having the same skill and resource as before the amputation, as many as 30% of amputated experience depression or anxiety owing to unexpected events and as a result of congen- con- congenital defenses and vascular condition, amputation may be achieved. Okay, aims for this project is human being losing their part of human body at a younger age. That is hands, legs, and so on. Using a wooden or metal prosthetic pieces, they replace the part, but there were also restriction and limitation to that. It was a sticky body part only. It was made from wooden or metal material which would rise the structures weak. It was painful to bring body part because of that. Another disadvantage was it would generate resistance, resistance, resistance to the normal motion of the body. It's just a useless human part or at a certain point for aesthetic standard, that would be only reason human did not even one prosthetic hand. They want properly functioning prosthetic hand to replace them. As mentioned before, only providing the prosthetic hand is a primary origin for this invention. After that, there was a lot of advancement throughout this field, and where we had to completely functioning processing hand every day that could do much and of any usual human hand function. As mechanical, electrical, electronic, and communication technology enhancement and growth too, we had technological gadgets such as sensor that would allow the processing hand to provide precise, precise, precious and desired movement. Okay, for the objective for this project is we have aimed our project in direction to providing a cost-effective practical human kinetic hand because of the above reason. First, we have to produce it cost effectively to have eventually quite a suitable manufacturing process for our project. So we come out with a method of additive processing. We can lower production costs through additive manufacturing process. So we were fulfilling the aim of innovation to provide a cost-effective practical kinetic hand in this way. Okay, the scope for this project is to study the potential of additive manufacturing to produce kinetic hand, research on the relationship between a kinetic hand and additive manufacturing.
Hi, Assalamualaikum and a very good day to everyone that is listening to this video, that is watching this video. My name is ALYANI binti Mama HAZLI, and I will be representing about literature review. So what will you get in detail about this chapter is basically this chapter is to review articles, books, dissertations, conference proceedings, and resources that are applicable to 3D printing machine, and especially our product, Kinetic Hand. The purpose of this review is to review previous studied regarding our products, such as manufacturing processes, analysis of materials, and the method that is involved. So, as a result, a variety of sources were identified and will be reviewed subsequently. So, also one of the reason that we are doing literature review is also to strengthen our understanding about the study that we are doing right now by taking into considerations about the previous studies and researches. So firstly, I would like to talk about 3D printing. So 3D printing is like one of the best invention that has happened in the engineering world because it is so easy to conduct. It is so easy to conduct. So in general, they have two important steps. This is in general, roughly, we're talking about 3D printers. So the two general process is first is 3D application software, where we generate the design in the software. Next will be slicing, which is 3D printed to printable image. So basically, first we will produce the product using a software, and then the design will be transmitted to 3D printer to be printed. And there you go, a product. That is how easy it is using 3D printing. So next is prosthetic hand. Frigo said that a prosthetic hand is an artificial limb intended to replace a missing hand between amputees. In multiple events or illnesses, amputees may have lost their hands. A prothesized hand can be planned and built in a variety of ways with different results and relevant targets. Some amputees may possess more than one prosthetic hand, with the objective to use more aesthetic for ceremonial activities, and another prosthesis for more physically challenging activities like writing, carrying object. So basically, prosthetic hand is not really a need sometimes. It is also a want. Like some people, they would use prosthetic hand, but with no definite reason, definite function. So they use prosthetic hand just because of using it, just for the sake of using it, but with no related functions. Next is about aesthetics. So most prothesized hands appear like a real hand in its physical characteristic. A prosthesis hand is built in many ways to accomplish this requirement, including 5 fingers, correct finger, and hair measurement. There are many solutions on the market today that incorporate plastic sockets that look like human skin. These solutions can further increase the cost and weight of the product, but often are a better solution for the client as aesthetic similarities are often very highly valued amongst customers. So the problem with prosthetic hand is that sometimes people use it just for the sake of it is aesthetically pleasing, not because it's a real need. So prosthetic hand, you cannot cut the aestheticness with prosthetic hand because it takes a lot of time to build it, and it takes a lot of work just to produce a prosthetic hand. But with kinetic hand, you can produce it in the ways you want, like in a ways that will please you in terms of aesthetic. You see, so that's one of the reasons why kinetic hand is a must. Next is functionality. Another essential factor in the development of artificial limb is their capacity to operate at levels comparable to the limb they are intended to initially replace. So prosthetic hand, you can um, produce it in a way how real hand would operate, but it would take a lot of effort and amount to produce one. But with kinetic hand, you can use just 3D printer, and with the right material, with the right measurement, it will operate just like a real human hand can do. So, an example of this would be a hand. When a hand can lift a certain weight or press on a certain amount via his fingers, the fingerprint is also a top priority for the limb to replicate human movement as realistically as possible. A prosthetic limb can prove to disrupt the development of the limb aesthetic resemblance to real life, with the sole objective of optimizing their physical strength and their overall sustainability. Design processes must also typically balance time and effort between elements of the prosthetic limb, similarity and functionality, as more human design often prevents the positioning of mechanical components needed for stronger physical attributes. So basically, um, kinetic hand is also produced to provide the function as good as a real hand. That prosthetic hand might took a really lot of effort to produce. So that's all from me from for literature review.
Assalamualaikum. My name is Muhammad Aiman Mustaqim bin Arif HAZMI, and I will be presenting the methodology of all product, which is prosthetic hand, and the new product, that is kinetic hand. Now, I will go through to the presentation flow. The first one will be the reverse engineer flow. Second, product description. Third is mechanism of old product. Fourth will be the mechanism of new product. And lastly, the fabrication of kinetic hand using 3D printing.
So, for the first topic is reverse engineer processes. What is reverse engineering? Well, reverse engineering is the method that analyzing and reconstructing an item in a 3D model. We can use 3D scanning technologies such as laser scanner, light digitizer, and CMM, which is coordinate measuring machine. To get the original shape of the prosthetic hand, first we must scan it to be processed and reconstructed via the 3D model. After that, the 3D model will be analyzed to fit in the hands of the disabled people.
Next is the product description. The main use of the prosthetic hand is to replicate the natural hand movement for disabled people. Now, there are lots of different styles and patterns of prosthetic hand based on the disabled people's favorite. The modern prosthetic hand have evolving from the previous mechanical hooks to high electrically driven devices offering large DOF, which is degree of freedom. Unlike previous prosthetic hand, it only operated with mechanical movements, whereas the modern devices provide more for complex actions. Now, we go through the mechanism of all product, which is prosthetic hand. The prosthetic hand is a mixture of different connection, level in an open or closed core, which suitable joints to make disabled people comfortable to use the prosthetic hand. For typical prosthetic hand, they are operated by the body, consists of the core or framework, the suspension, brace harness, cable power, gripper, and unit wrist. For the mechanism of new product, which is the kinetic hand, it has more simple mechanism as shown in the slide, one of which are flexible tensioners, flexible wrist hinges to move the finger, the soft customizable insert to make people comfortable for wearing it, and the more silicone grips for easier to grip the object. The kinetic hand will be fabricated by using the 3D printer. As shown in the figure, various printed parts has been fabricated to make the product lightweight and easy to use. That's all for my presentation. Now, my friend will be presenting the discussion part. Thank you and Assalamualaikum.
Hello, my name is Mohamad HILMY, and I'm going to present about the discussion of the report. Here's the presentation flow. Number one, the comparison of the prosthetic hand and kinetic hand. Number two, the part reduction or increasement. Number three, the feasibility and improvement. And number four is the FA analysis. So number one, the comparison of prosthetic and kinetic hand. So the manufacturer of a prosthetic arm is based on two types of plastic product, which is injection molding and vacuum forming. First, a mold of residual limb will be made, which is a similar process to dental mold in fabricating dentures. All of the information about the location of smaller bones, tendons, and muscle must be well provided in this process. Next, liners are being used as a covering product protective, which is typically made of medical grade silicone, followed by a fitting process by using a thermoplastic sheet. Thermoplastic sheets usually are made of a polyethylene and polypropylene. Next, by using a heating system, modifications are quickly made to maximize the mobility and comfort. custom sockets are used to spread mechanical pressure uniformly around the amputation site and the interface of prosthetic limb. Compared to the 3D kinetic hand, the manufacturing method used is by using additive manufacturing. The first process is the hand measurement using the 3D scan. The 3D scan is the perfect situation for scaling a kinetic hand to the correct size. For digital fitment, a 3D model must be created. And then, after the 3D model have been created, we go to a slicing process using the slicing tools, and then we convert it into the 3D printing machine. And then we set up the printing setting process parameter, such as this table. There are basically two types of filament that can be used, which is TPU filament and PLA filament. All of these process parameters must be taken seriously in order to produce a good quality of products, which is the kinetic hand. Next is a part reduction or increase. To determine the percentage of part reduction, these tables are made for a better viewpoint of the number of parts involved in both products side by side. So as seen in the table, there is 9 number of parts in both prosthetic and 3D kinetic hand. Hence, it is safe to say that there is no increment or reduction part or 0% of percentage of part reduction or increasement. Next, the feasibility and improvement. There are basically two types of improvement in this project, which is number one, the build time. In injection molding, it takes quite a long time to complete one process cycle because it requires several steps. One of the steps is to create the mold first and then measure how well the prosthetic hand suits the residual limb. Compared to the 3D kinetic, it uses 3D scanning, which is relatively fast scaling to the correct scale. The second terms is for the gripping ability. In the prosthetic hand, it uses a harness and cable system, which allows a body-powered prosthetic hand to operate rather than to use the external energy source. It is called a self-closing prosthetic hand, where the hand will automatically open but needs to be pressured to close. So this is difficult because when a person with limited strength did not have adequate pressure to close the grip of the hand. Compared to the 3D kinetic hand, it used a combination of flexible tensioners and individual tensioner adjustment system that allows the individual fingers to close while other fingers begins to move. Also, there is no interconnection between fingers, which makes for equal distribution of grip over a wide variety of different object forms. The last is the FE analysis. As you can see, we conducted the 3 types of external load, which is stress, displacement, and strain. So based on this study result, this product is actually safe to be used because as you can see, there is no other fracture that can we see in this analysis. Thank you.
So for recommendation, it has a lot to be recommended towards the betterment of the kinetic hand that can be produced in sooner or later. So for conclusion, the project was done with a complete and fully produced kinetic hand, and the benefits and drawbacks in contrast with existing consumer goods. A deeper understanding of kinetic hand design and creation was achieved by studying the market, AMG, machine learning application, hardware, gears, finger mechanism, and material. A formal reasoning may be used to prioritize certain aspects of the development of a hand by balancing concept from expense, functionality, and aesthetic. After a number of analyses were performed to verify material strength and mechanism functionality, the completed hand meets the necessary requirements and function. Further analysis and measurement of grip strength were gotten from the analysis because of the limited time available. Further development regarding the 4DOF concept are strongly encouraged as an economically workable concept configuration on the current kinetic hand market could prove quite beneficial. The engine compartment could be fitted in the fingers in a similar way to the thumb configuration by using a smaller flexing or extension engine. The free palm could then be used for the abduction process of the housing. Two variants in this definition could implement motorless physical movement and motor-driven movement. In addition, comprehensive research into soft materials that are to be employed on the fingertips may improve finger grip capabilities. This will greatly improve motor skills and accuracy as you grasp small objects and move sensitively. Further long-term usage and where analysis are required to provide amputees with a long-life product. Lastly, the sound analysis with appropriate software is also strongly encouraged to obtain knowledge about the loudness of the motors used and the mechanism used. So that's all for conclusion and recommendation.